Warahmatullahi wabarakatuh, and very good morning to everyone. Today we will continue with the chapter 5, which is secondary or biological treatment process. Okay, so for the introduction, biological treatment is the process that remove organic contaminant from the industrial and municipal waste water. So dalam biological treatment, it involves the microorganism which will degrade or remove the organic contaminant in the wastewater to form the food and energy sources. And there are two types of biological process, such as the aerobic bacteria, which widely used for the wide range of organic substrates utilized by the bacteria, and then the second one is the anaerobic bacteria, which is to treat the high strength organic waste and treat sludge. So kita ada dua types of bacteria. So kalau aerobic bacteria, maksudnya dia digunakan dalam aerobic decomposition system. Kalau dia anaerobic, dia mestilah digunakan dalam anaerobic system. So aerobic dengan kehadiran oksigen, anaerobic without kehadiran oksigen. So dalam biological secondary treatment ada tiga types of process system, which is suspended growth, attached growth, and dual biological treatment. This dual biological treatment is combined between suspended growth and attached growth, but we will focus more to the suspended growth and attached growth in this chapter. So in the classification of bacteria, so untuk kita classifykan bacteria ada beberapa kriteria. So the first one is due to the trophic level, which is autotroph bacteria. So this autotroph bacteria obtain their carbon from the inorganic sources such as carbon dioxide, and then it will use the energy from the light and inorganic chemical reaction. Meanwhile, for the heterotroph bacteria, these bacteria are unable to utilize the inorganic carbon. So this one utilize the inorganic carbon, inorganic sources. However, for heterotrophs, cannot use from the inorganic carbon. And this bacteria also cannot synthesize their own food, but obtain the energy and carbon from the organic compound. So it needs the organic compound to obtain energy and carbon. Meanwhile, for the heterotrophs, the energy come from the light or the inorganic chemical reaction. So dia adalah sebaliklah to each other. Okay, next is the criteria is based on the temperature. So kita ada psychophiles, mesophiles, thermophiles, and stenothermophiles. So all of these bacteria will grow best at the certain range of the temperature. It will provide BOD removal, which cannot be achieved in the primary treatment process, and also will remove some of suspended solids, which also cannot be achieved in the primary treatment process. And in the aerobic biological degradation, the organic carbon will add with the oxygen and produce carbon dioxide and H2O. So basically in the secondary treatment, the objective is to allow the BOD to be exerted in the treatment plant rather than in the stream. So in the biological treatment process, it will add the microorganism to degrade the organic contaminant with the presence of oxygen to produce carbon dioxide and purified water. Okay, how the process is accomplished in the secondary treatment basically is from the creation of very high rich environment for the cell growth of the diverse microbial community. So maksudnya dalam secondary treatment, dia membiarkan lagi banyak microorganism, and this microorganism bila dia terlalu banyak, dia boleh degrade more organic contaminant in the wastewater, and then it will reduce the amount of BOD in the wastewater stream at the end of the wastewater stream of the secondary treatment process. Okay, next is the example of the microorganism which used for the wastewater treatment process. Okay, in the decomposition of the waste in secondary treatment, kita ada 3. Yang pertama, aerobic decomposition, anoxic decomposition, and anaerobic decomposition. So this all is the example of the bacteria which used in each process. So this 3 is important, you need to remember. And then in the secondary system, by the aerobic decomposition can be categorized into 3 parts, which is suspended growth, attached growth, and dual biological. So these 2 also you need to remember. It is important for this chapter. So in the secondary treatment, aerobic secondary treatment, there are many microorganisms, organic material, oxygen with a favorable environment, which is temperature and sufficient time. So the organic material from the wastewater will accomplish by the microbe which convert, coagulate and dissolve organic matter into the gases and protoplasma. So maksudnya dalam wastewater kita ada organic material. So this organic material will be convert into the gases and protoplasma in the presence of oxygen, di mana microbes dia akan degradekan organic matter tadi into food and energy. So from this food and energy, dia akan membiak lagi banyak. So bila dia membiak lagi banyak dia akan degradekan wastewater dalam organic contaminant dalam pollution tu untuk menjadikan gases dan juga protoplasma. Basically it will produce carbon dioxide and H2O. Okay, so this is the aerobic decomposition. So in the presence of oxygen, this organic matter will produce new cells, energy, carbon dioxide and H2O. So it must have the oxygen. So dia kata kat sini, organic material oxidized aerobically by microbes, resulting in large production of new cell, generate sludge. So maksudnya organic material is from the wastewater will be oxidized since it have oxygen, and then will produce new cells. New cells ni maksudnya terdiri daripada dead and living cells, iaitu dalam kita punya sludge lah, sludge yang terhasil. And then it will form energy, carbon dioxide dan juga H2O. So this H2O basically the treated wastewater. Okay, this aerobic decomposition is suitable for the low strength of wastewater, and high strength wastewater not suitable because it is difficult in supply enough oxygen, and also because of the amount of sludge produced. So for the high strength of wastewater, basically it will contains higher amount of sludge, therefore it will need more supply of oxygen, and then this will cause a problems to the in terms of costing, which is we need the oxygen more, so it will costing. And then it also will increase the maintenance cost since it produce a large amount of sludge. Okay, this is the example of aeration tank in the aerobic treatment. Okay, next is the anaerobic decomposition. So in this anaerobic decomposition is occur in the absence of oxygen, also called as a fermentation process. So in general it have a two-step process, which is the first part is complex organic compounds are ferment to low molecular weight volatile fatty acid, and then secondly the organic acid are convert to the methane. So in this anaerobic decomposition, it will yield carbon dioxide, methane and water as a major end product. So kebanyakannya dia akan menghasilkan methane lah, yang membezakan antara anaerobic dan juga aerobic adalah methane gas ni. So this is the secara terperinci untuk proses yang berlaku dalam anaerobic decomposition. So tadi secara general dia ada 2 step. So secara terperinci dia ada 4 step lah. 4 step So 4 step ni adalah reaction yang involve during anaerobic decomposition. So kalau saya tanya step, maksudnya yang inilah. So from the complex organic matter, which is the high strength of wastewater, so dalam this complex organic matter kita ada carbohydrate, protein or fat. So it will go to the hydrolysis process and form the soluble organic molecules, which is dia akan kecilkan lagi daripada carbohydrate, protein dan fat, kecilkan lagi menjadi sugar, amino acid and fatty acid. And then it will go to the fermentation process. This fermentation process tadi yang bila tak ada oksigen, so the fermentation, and then dia akan menghasilkan volatile fatty acid, and then juga acetic acid, H2 dan juga CO2. So from the volatile fatty acid, it will go acetogenesis to produce acetic acid also, H2 and CO2. So bila ni sangat banyak, so bila dia melalui proses methanogenesis, dia akan produce methane dan juga carbon dioxide. So from this acetic acid, H2 and CO2, it will produce methane and carbon dioxide. So inilah the end product yang paling banyak dalam anaerobic decomposition. So there are 2 conventional operation temperature level for anaerobic digester, which are determined by the species of methanogens in the digester. So the first one is mesophilic, which is around 30 to 38, and then thermophiles, which is 49 to 57. So this is the general figure for the aerobic and anaerobic. So kita boleh tengok kat sini, untuk aerobic, it will produce more sludge. For the anaerobic, it will produce more biogas. Okay, so this is the difference between the aerobic and anaerobic. So bila aerobic tadi produce more sludge, and for the anaerobic dia akan produce more methane tadi. So untuk case aerobic ni susah sikit lah, sebab kita nak kena manage sludge yang banyak. Sludge terlalu banyak pun akan menyebabkan problem to the next treatment process. And that's why this aerobic system not suitable for the high strength of wastewater compare with the anaerobic system, because most of the sludge will convert into the methane gas. Okay, next is the anoxic decomposition. So a biological process in which certain group of microorganisms use chemically combined oxygen, such as that found in nitrate and nitrite. So untuk case anoxic decomposition, basically dia adalah pertambahan nitrate dan nutrient. So daripada sini akan the organic matter will use the oxygen from the nitrate and nitrite to produce nitrogen gas, carbon dioxide, stable solid, and more organism lah.